This review is going to cover chapters 6 through 8. So you need to follow along on your handout and write down the sample problems as we go through them. This will be your study guide for you to go back through chapters 6 through 8 on your exam review packet so that you'll be able to work those problems out based on the notes that you take on these sample problems. We're going to start with chapter 6. The first thing we did in chapter 6 was we found the x and y intercepts, and then we used those to sketch the graph of the line. So for this first example, we have x minus y equals 4. To find the x and y intercepts, you are going to set the opposite variable equal to 0 and solve. So for this one, we have x minus y equals 4. If I want to find my x-intercept, that's where it crosses the x-axis, then I am going to plug a 0 in for y. So I have x minus 0 equals 4. And you're going to get x equals 4. That is my x-intercept. So on the x-axis, I will go to positive 4, and I will make that point there. We're going to do the same thing for the y-intercept. We're going to plug in a 0 for x. So we'll say 0 minus y equals 4. In this case, we still have a negative 1 in front of our y. So to finish this, we are going to have to divide by that negative 1. So our y-intercept here is negative 4. So we're going to go on the y-axis to negative 4 and put that point. Once we have both of our points, we are going to connect those lines and connect those dots, and that will be our line. And so you connect those dots, put an arrow at the top and the bottom, and you have sketched the graph of that line. The next portion of this chapter deals with slopes and slope-intercept forms of lines. So if you'll recall your slope formula, you do have to know. So to find your slope, remember you subtract your y's, that is your numerator, and you subtract your x's, that is your denominator. So you do need to know the slope formula, y2 minus y1 equals x2 minus x1. And then if you just write above each group, the first group you can write x1, y1, the second group you can write x2, y2, and now you can just take those and plug them into your formula. y2, negative 12, minus y1, that is a negative 18, all over x2, 9, minus x1, negative 4. It's always subtraction for this, so in this case, I'm subtracting a negative, so I do apply my subtraction rules. When I'm subtracting a negative, that is adding a positive. Same thing on the denominator, adding a positive. And so I'm going to get negative 12 plus 18 gives me 6. 9 plus 4 gives me 13. If I could reduce it, I would, but this one does not reduce, so I'm going to leave it as 6/13. For the next few problems, you're going to see the same equation over and over. It is the slope-intercept form of the equation, and that is y equals mx x plus b. If you'll recall, the m, the number in front of the x, is your slope. The b, which is the number that does not have an x with it, is your y-intercept, where it crosses the y-axis. And so for this one, they gave us our slope and they gave us our y-intercept, so we're just going to fill those in. If they want the slope-intercept form of the equation, we're going to say y equals, and we're going to put this number in for our m, 1/5 x, plus we're going to put this in for our b, -1. And remember, plus a negative is the same thing as minus. So y equals -1/5 x minus 1. These next couple problems deal with the same exact formula, your slope-intercept form. So we are still going to use y equals mx plus b. But instead of giving us m and b, they actually gave us m, which is our slope, and they gave us the x, y. Well, when you have your slope-intercept form, you only fill in the m and the b. You leave the x, y as variables. So what we're going to do is we're going to use that xy to figure out what b is, but then we're going to go back and rewrite that y equals mx plus b, filling in our m and our b. So we're going to fill in this time the y, the m, and the x to solve for b. So we're going to say y, which is 3, equals m, which is -3/2, times x, which is -2, and I'm going to write that -2/1, plus b. And so now we're going to solve for b. Remember, we can cross-cancel because we are multiplying fractions, so we can cross-cancel these 2's. And now remember, we have a negative times a negative. So this is -3/1 times -1/1, which is just -3 times -1. So we have 3 equals +3 plus b. To solve for b, we're going to subtract that 3 over. Cancels here. 3 minus 3 is 0. So we actually get that b equals 0. We're going to rewrite my slope-intercept filling in our m, which they gave us at the beginning, and our b, which we just solved for. So we're going to say y equals -3/2 x plus our b, which is 0. Now, if this were any other number, we would leave it just like this, but adding a 0 really is unnecessary to leave, so we can just say y equals -3/2 x, and that is our slope-intercept form. The next problem is very similar, but we're actually going to use two equations here. To find the slope-intercept, we need our slope. They did not give us our slope. They gave us 2 points. So we are going to have to use our slope formula first to figure out our slope. Once we have our slope, we can use either one of these points and do exactly what we did on number 4. So we'll also have to use our slope-intercept equation, which is y equals mx plus b. So the first thing we're going to solve for is that m, that slope. So remember to solve for slope. Label your points x1, y1, x2, y2, and then just plug it into your slope formula. We have 3, which is y2 minus y1, all over x2 minus x1. On the top, 3 minus 1 is just 2. And on the bottom, we're subtracting a negative, so we're adding the opposite. Negative 3 plus a positive 4 is positive 1. So our slope here is 2. So now we can use either point. I'm just going to use the first one. And we are going to plug in our y, our m, and our x to solve for b. So our y for this point is 1 equals our m we just solved for, 2. Our x is negative 4 plus b. We have 1 equals negative 8 plus b. To solve for b, we're just adding 8 to both sides. So b equals 9. Now we know our m, we know our b, and we're going to go back and plug in our m and our b to get our slope-intercept form of this equation. So y equals m, which was 2, x plus our b, which was 9. And that is our slope-intercept form of this equation. The next two problems deal with graphing. The first one is just graphing a line. So if we graph a line, if it is already in slope-intercept form, then we are going to use that to graph. We are going to start at our y-intercept. Now remember, when you graph when it's in slope-intercept form, you always start on your y-axis. So I go to positive 1 on my y-axis, and I'm going to draw a point. All right? The next thing we look at is our slope. Our slope is 3 over 2. Remember, the top number tells me to move up or down. The bottom number tells me to move left or right. So I have a positive 3 over a positive 2. So I want to go up 3 from here. So 1, 2, 3. And I want to go right 2 because that's positive 2. 1, 2. And I'm going to put that second point right there. And once I have 2 points, I can draw my line. I just connect those 2 points. And so I'm just going to connect those 2, draw my arrows at the top and the bottom, and I have sketched the graph of that line. The next problem is an inequality. So this one has a greater than or less than sign. That's how we know it's an inequality. So what we're going to do is we are going to take that function and we're actually going to put that in slope-intercept form first. And so I am going to move my x over and then divide by the number in front of my y. So I'm going to move this 9x over to the other side. Now remember, when I do that, it changes signs. So it's a positive 9x over here. I'm going to move it to this side. So on the left-hand side, I'll still have a negative 5y. Don't forget your greater than sign. And over here, I have moved the 9x. It is now a negative 9x minus 20. That stays the same. I do need to divide everything by the negative 5 because I need the y completely by itself. So I'm going to divide this by negative 5, the 9x by negative 5, and the 20 by negative 5. Okay? So a couple of things about this one. I now have the y completely by itself. So on the left-hand side, I have a y. I divided by a negative. Remember your rules for greater than, less than. When you divide by a negative, you flip that sign. So we're going to flip that to a less than. If I have a fraction like this, the 9 over 5, I can leave it that way. So negative 9 over negative 5, remember a negative divided by a negative is a positive. So I have 9 over 5 times x. And now I have negative 20 divided by negative 5. Negative divided by a negative is positive, so this is positive 4. And now it is in slope-intercept form. So now I'm ready to start graphing. I'm going to start on my y-axis always at my intercept, positive 4. Now my slope is positive 9 over positive 5, or I could say negative 9 over negative 5. That will also be a positive, right? Because if I were to go up 9, I would go off the graph. So I'm going to do this movement so I stay on my graph. So I am going to go down 9. So I'm going to say 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'm going to go left 5. So I'm going to say 1, 2, 3, 4, 5. And that's where I'm going to put my second point, all right? Now for a line, I would just connect these dots. But we now have to look at this right here. So a couple things about this. All right. If you'll recall, if it is just less than or just greater than, we have a dashed line. Okay? If it is less than or equal to or greater than or equal to, we have a solid line. So because this is just a less than, I am going to do a dashed line. So I'm going to connect these two with a dashed line. Okay? So I do this, connect those dots. I still do my arrows. All right? Then we decide how to shade. All right? If it is less than or equal to, we shade below. And if it is greater than or equal to, we shade above. All right? So for this one, it is less than. So I'm going to shade below the line. So I can look at my y-intercept and I can say, well, there's a positive 4. Below the line would be positive 3, positive 2, positive 1. All of this area below the line is what I am shading. And that is my answer to the inequality. Chapter 7 deals with solving systems of equations and systems of inequalities. So the first way that we solved systems of equations is by graphing. So we are going to graph these lines exactly like we graphed the prior chapter. We're going to graph each line using our slope and our y-intercept, and then where the lines intersect will be our answer. So we're going to start with this first graph. We always start with our y-intercept on the y-axis. So this one is at negative 8. My slope here is negative 1. So negative 1 over positive 1 or positive 1 over negative 1. Those are the same exact movements. So I can either go down 1 and right, or I can go up 1 and left. Both of those are a negative 1 movement. And then I am just going to connect those dots. So I'm going to draw a line that connects those dots to sketch my line. And that is my first line. I'm going to do the same thing with the second line. So the second line starts at negative 3. Remember, always on the y-axis. And then my movement here is negative 1/6, which is negative 1 over positive 6, or positive 1 over negative 6. Both of those are fine. So positive 1 over negative 6 would tell me to go up 1 and left 6. 1, 2, 3, 4, 5, and 6. And you can see that they cross right there at that point. So I'm going to connect those dots. And my answer is going to be where they cross. So this point right here is my answer. You're going to tell me that point. My x value is negative 6. My y value is negative 2. So my answer here is going to be negative 6, negative 2. The next method that we used to solve was substitution. So for substitution, you have to have one variable completely by itself. So I'm always going to look for the equation that has a variable that's almost by itself. If you look at the second equation, the x is almost by itself if I just move that 4y over. So I am going to rewrite the second equation. X equals, and I'm going to move the 4y over. Remember, when you move it across the equal sign, it changes signs. So it was a plus 4y, it's going to be a minus 4y, and that's still a positive 7. So now that I have a variable completely by itself, I am going to substitute it into the opposite equation for that variable. So x equals negative 4y plus 7. I'm going to plug that in for x. So now I'm going to rewrite the top equation, 2. And instead of x, I'm going to write negative 4y plus 7. Then I have my minus 4y equals 2. And now I'm just solving. Remember, to get rid of my parentheses, I use distribution. 2 times negative 4y is negative 8y. 2 times 7 is 14. Minus 4y equals 2. I'm going to combine my like terms. So I have a negative 8y and a negative 4y. That's negative 12y plus 14 equals 2. Subtract the 14 over. Negative 12y equals negative 12. And then divide by negative 12. So I know that y equals 1. I'm not done yet. I need to go back to this equation and I need to solve for x. So if y equals 1, x equals negative 4 times y, which is 1, plus 7. X equals negative 4 plus 7, which is 3. So now I have my x value. I have my y value. Remember, you always want to write it x, comma, y. So x is 3, y is 1. And that is my answer. The next method that we used was elimination. So this method is also called addition because what we're trying to do is we are trying to add the two equations and eliminate one of the variables. And so I usually try to eliminate the easiest variable. In this case, they're both fairly simple. I could eliminate the x, but I would need to have a -6 and a +6. So I could multiply this whole equation by 3, and I would get a -6 and a +6. Or I have a -y and a -y, so I could multiply one of the equations by -1, and then I could eliminate my y's. So I think we'll do the second one. We will multiply one of the equations by -1. So I'm going to leave the first equation alone, -6x minus y equals 8. And then I'm going to multiply every piece of the second equation by -1. So -1 times 2x is -2x. -1 times -y is +y. And -1 times -8 is +8. And now you can see I have one of my variables that has a positive and negative of the same number. So now I'm just going to add these two equations together. -6x plus -2x is -8x. Y plus y zeroes out, which is what I want to happen. +8 plus +8 is 16. Now I need to solve for my x. Divide both sides by -8. X equals -2. Remember, I'm not done until I have both variables. So I'm going to go back to either one of my equations and plug in the x. So if we use that second equation, we have 2, and instead of x, we're going to write what x equals, -2, minus y equals -8. So I just used that second equation here. -2 times +2 gives me a -4 minus y equals 8. If I add 4 to both sides, then I'm going to get -y equals -8 plus 4. And then I'm going to divide both sides by -1. And I'm going to get y equals 4. And so my answer here is going to be -2, +4. So these next problems deal with downstream and upstream. So remember, downstream is with the current. So my rate of travel is going to be how fast the boat is traveling plus the current times how fast I'm going, the rate. Okay. The distance upstream, so downstream, that's what the distance is going to look like. And upstream, the distance is going to have the current going against it. So we're going to say the boat rate minus the current times the time is going to be that rate. And so we're going to do that for this problem. A boat traveled 176 miles, that is the distance, each way. So, of course, if we go downstream or upstream, if we use the same path, it's going to be the same distance. The trip downstream took 11 hours. The trip back took 22 hours. Find the speed of the boat in still water and the speed of the current. So, downstream, that is my boat plus my current. That is the rate. And my time, they said, was 11 hours. And that is going to equal 176 miles. Upstream, remember I have to subtract my current. The trip back took 22 hours, and that was also 176. All right. Now remember, we can go ahead and get rid of that time by dividing both sides by the 11. It is divisible. So remember, if we just do 176 divided by 11, 11 goes into 17 one time. 7 minus 1 is 6. Bring down the 6. 11 goes into 66 6 times. So 176 divided by 11 is 16. So I can divide that out, and I can say that's going to be B plus C equals 16. Same thing with the 22. Divide by 22. And in this case, even if you don't see it, it's going to be fairly simple because we just divided by 11. So 22 actually goes in half as many times. So the B minus C is going to equal 8. Now this is set up perfectly for an elimination. If I just add these, my C's will cancel. And so I have B plus B is 2B. C and negative C will cancel. And 16 plus 8 is 24. To solve for how fast my boat is going, divide both sides by that 2, and my boat is going 12 miles per hour. Now I'm not done. I need to plug that in. So if you look right here, B plus C equals 16. I just solved for B. 12 plus what equals 16? Well, if I subtract 12 from both sides, C will equal 4, which tells me my current. My current here is 4 miles per hour. We ended chapter 7 with solving systems of inequalities. And these are pretty straightforward. You are going to graph those inequalities just like we did in the last chapter. And then where the two shades overlap is going to be our answer. So we've done this many times at this point. We are going to start on my y-axis. At my y-intercept, the first one is positive 1. And then we are going to move according to our slope. Our slope here is negative 1/2. Remember, that's negative 1 over positive 2, or positive 1 over negative 2. So if I go down 1 and right 2, that's where my second point is. And so I can connect those dots and then decide if I am going to do it solid or dashed, just like we did before. And if you'll recall, if it is just a less than and doesn't have the equal to, remember you're going to do it dashed. And so we're going to do this line dashed. Then I'm going to look at my shading. Remember, if you're trying to shade, if it's less than, you're going to shade below the line. So I'm going to shade this one below the line. Then I'm going to do the same exact thing with the next line. I'm going to start at my y-intercept. In this case, it is positive 8. My slope is negative 9/4, or of course, positive 9 over negative 4. I'm going to go down 9, so 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'm going to go right 4, so 1, 2, 3, 4. And again, this is dashed because it is just greater than. So I'm going to connect those two dots again with a dashed line. And for this one, it is anything above the line. Well, above the line is over here. So you'll see this one is over here. And my answer for this is where they cross. And they're going to cross in this little wedge right here. And so this wedge is actually my answer. And you're welcome to shade lightly and then darken what your answer is, as long as I can tell what part of the graph is your answer. All right, Chapter 8 is where we're going to finish today's review. And this is all about properties of exponents. So just to review the properties of exponents, when you multiply like bases, then remember you add their exponents. When you divide like bases, remember you subtract their exponents. When you have a power to a power, you multiply the exponents. And then a couple of special ones. Anything to the 0 power is just the number 1. And anything to a negative power just puts it in the denominator. We do have a couple things like when you have a group to a power, then everything inside the group is also to the power. So if you look at this first one, deal with your numbers first. I have 4 times 4, so put those together. Then I have my x's. I have x to the 4th times x cubed. And then I have y's. I have just y to the negative 1. So to simplify this, I just multiply my numbers. 4 times 4 is 16. My x's, I'm multiplying like bases, so I'm going to add those. 4 plus 3, I have x to the 7. And then the y, well, that's a negative exponent. So remember, that's the same thing as multiplying times 1 over y to the first power. And so if these don't have a denominator, you can just put a 1 there. And now we're going to multiply across. 16 times x to the 7th times 1 is 16x to the 7th. And then 1 times y is just y. And that is my answer. Let's look at the next one. If I do not have a coefficient, remember it's a 1. So I'm going to just do the division of my numbers. 1 over 3, well, that really cannot divide. And so we're just going to leave that as 1/3. Let's look at our x's. We have x to the negative 2. And since we're dividing, we are subtracting. So negative 2 minus 3. And then for my y's, I have y to the negative 2 minus a negative 3. So I'm going to leave that 1/3 alone. Negative 2 minus 3 is negative 5. Negative 2 minus a negative 3 is plus a positive 3, so that's positive 1. Because this one was a negative, it's going to go in the denominator. So I have 1/3, and I have 1 over x to the 5th. And remember, y is to the first power. It doesn't have a denominator right now. We're just going to say over 1. Then multiply across. 1 times 1 times y. That's going to give me y in the numerator. And 3 times x to the 5th times 1 is 3x to the 5th in the denominator. The last one here is a group, so we're going to take everything in the group to this power of 4. So I have 3, and I'm going to take that to the 4th power. I have x to the 0 to the 4th power. And then I have y to the negative 3rd to the 4th power. 3 to the 4th power, I can actually multiply that out. That's 3 times 3 times 3 times 3. And that's going to give me an 81. For these, I multiply 0 times 4, that is 0. Negative 3 times 4, that is negative 12. Now remember, anything to the 0 power is just a 1. So I have 81 times 1 times, remember this is in the denominator, 1 over y to the 12th. And these were just over 1. Then I multiply across. 81 times 1 times 1, that is just 81. 1 times y to the 12th is just y to the 12th. And that is my answer. The last thing we did in this chapter was scientific notation. So remember, for scientific notation, the number has to be between 1 and 10, and it cannot be equal to 10. And then we're going to multiply by 10 to some power. If I have a number bigger than 10, this is going to be positive. So that's all numbers larger than 10. And if I have a number smaller than 10, this is going to be negative. Or smaller than 1, rather. Smaller than 1. And so if I look, 430 is larger than 10. So I am going to see how many places I need to move it to get it between 1 and 10. So I need to move my decimal over 2 places to get that between 1 and 10. That would make it 4.3. And because I moved it 2 places and it was larger than 10, it's to the positive 2 power. If I'm going the other direction from scientific to standard, this number tells me how many places to move it. So I started at 7.5. Because that's a positive 2, this is going to get bigger. So I need to move it to the right 1, 2 places. Remember, any place that is left empty, I plug in a 0. So that is going to equal 750 in standard notation.